What is up, guys? We're back today with a video, kind of continuing what we were working on yesterday for the open table scraper with the N8 workflow. So yesterday we had worked through this like master sheet and this dishes sheet, and then what we were able to do was run this normalizer script, and then this normalizer script was able to give us this output that gave us, all this restaurant data, all the dishes data, and then gave us all the Firebase data that we were able to create, all the dishes for these two restaurants from the N8N. So that was just like one area of data that we had coming from an external source. Max had put together that N8N workflow. And then with those sheets, we take those and put them here, and then import them, normalize them, and then input them into Firebase. So what I have here is my local MySQL, and this has all these tables that we got from Open Menu. So Open Menu used to be a platform where, oh my gosh, please. So Open Menu used to be a platform that would integrate with restaurants, and then the restaurants would upload their menu items, and then Open Menu provides a bunch of like analysis and data, a lot of good analysis on menu items. So then now they've converted to chat. So I can just say like, find me pizza in Orlando, and then what this will do is it will index their database and then put that into AI, like ChatGPT or something, some sort of like AI to kind of like transpose all of the data from their database into a nice response here. So you can see like Pizza Bruno, Lazy Moon, Anthony's, Giordano. Pizza Bruno, so good. And it's got like all these tags and whatnot. But so the reason I bring up Open Menu is because we got a data dump from them. So they gave us a SQL dump of all of their tables, all of these OM tables here. Disregard all these other tables. These are for like a different project that I'm working on for a different company. But so yeah, all of these OM tables we got from them, and there's tons and tons and tons of records. So like this is the main table, like this RI, which is a restaurant item. So the way that their data is structured is they have a bunch of different restaurant rows for different addresses. So like, yes, this is a bunch of Applebee's, but this is specifically an Applebee's in West Memphis, Arkansas. And then this is one in Missouri, Kansas, Missouri. Let's run a quick query here to see. Select count star from OMF RI where state province equals FL. So what this is going to do is it's going to give us a count of all the records in this OMF RI table for Florida. So we're going to see how many Florida restaurants we have. Run that query. We've got 18,458. Awesome. So yeah, took me a while to kind of understand the structure of this data. I still don't really necessarily know it like the back of my hand, but so essentially like each restaurant has an OMF ID, and this is like the main table, and then each of those have menus. So like you can see like this is a OMF ID, and then the menu has an OMF ID. So like this ID will link back to one of these. So if I copy one of them, hopefully it shows. If not, okay, great. So yeah, this will link, and then it's got like so these are like just different menus, like cafe menu, like breakfast, lunch, dinner kind of stuff. And then it's got like currency, cool, all this stuff, name. But then, so for each of those menus, we've got menu items. So like we have this menu item ID, we've got the menu group ID, and then each of these hopefully link back to restaurants. So yeah, there we go, boom. So like this menu item here, which is Poncho's famous guacamole links back to Poncho's Villa. So there you go. That's how we connect these menu items to these restaurants by this OMFID. And so I'm using DataGrip here to view this data. I have a local MySQL server running on my laptop, and then what I did was just input this data to that MySQL server, then I can view it here and then write all these queries in the SQL language. So yeah, let's hop back into Cursor, and then I'll show you what I had built offline for this MySQL to Firebase normalizer. So yeah, MySQL is structured data, or like a kind of like a schema. So essentially, for those of you that don't know, SQL is structured query language, and then MySQL or MySQL is just a service that is able to run and store. So it's called a database manager, and then that goes down to like super deep level database management and stuff that I took classes on in college didn't quite understand that well. I mean, I really understand like structured data and schemas and like wireframes and like UML diagrams and all that, but so yeah, you can see like quick documentation on a table, and then this will show you kind of like how the table is structured. So like this is a query that it gives you to create the table, and then you've got like primary keys, and then each field has a unique type, and it needs to be that type. So like if I try to input I guess like let's just say like this menu item name, and it's a character, straight like a varchar is just like a string. So if I try to input a menu item name that's larger than 75 characters, it's not gonna like it. And then it's like all these constraints, so it's gotta have like a unique item UID here, and then here's like some indexes on like the menu items, group ID, OMFID. So it's got like indexes to make these faster. I don't think that any of these have foreign keys, so we'll have to like join those ourselves. Like normally, this would be a foreign key. It's just an integer right now, but normally this would be like a foreign key back to this table. And I don't think that we're working with any foreign keys here. Yeah, even no foreign keys here. Cool. So yeah, essentially like in a real production database, you'd have foreign key relationships to kind of connect all your data. You know, an example of that would be like, I'm a person, Grayson, and I have like many phones. So I'd have like a person's table and a phone's table, and then like each phone can only be with one person. So I'd have a foreign key on the phone to the person ID. So then that way, like I'm able to get like all the phones correlated to that person. Or like if I'm currently looking at a phone, like I'm able to step into that person and know like, hey, this is Grayson's phone, and then I can get all that information about Grayson and whatnot. Like it's very helpful in large production enterprise applications. So yeah, it's structured in that way to where we have these different tables, and then we've got the different types. And then so now what I'm tasked with today is taking this data dump from MySQL, and then we're going to normalize it to our Firebase structure like we saw yesterday with this open table N8N service. So then yeah, I'm just going to go ahead and do that for open menu. I already started, so what I did was I kind of like restructured this data directory. It was kind of gross before. It just had like all of these files in here. So what I did was I just structured it. So, you know, this is open table, this is open menu. So open table, I took this context that we have right here, and then I moved it to, I created a copy for open menu, and then I changed it just a little bit to kind of flow a little bit more with our MySQL to Firebase normalizer. So I'm saying like, here's my MySQL tables, here's my environment variables for connecting to my local MySQL service. And then here again is like the restaurants collection document structure, the dishes collection document structure, the category structure. Here's just some like example queries I gave it to understand a little bit more. And then like, here's the output tables that I want. So then, yeah, I already prompted Cursor to create the scripts for me. So it created the normalizer and the input script, or the import script. So let's just go ahead and kind of like go over these and code review what they have written so far. So we've got here a Firebase normalizer class, pretty standard. It's got initialization method, which just loads our .env here with all of our information. Set up logging, set up the MySQL connection with the host port user password database. So I'm using like the Gray Bay database here with all my tables in it. And then I've got a user and a password. This is running locally on my local host 3306. That's normally where all like local MySQL services run. So then what's going to do is use run down here to our main method. Normally, like your main method is where you can kind of understand the program flow to what's going to happen when I run this program. So it's going to instantiate the class, which sets up our MySQL connection. And then with that normalizer already connected to MySQL, we're then going to run this normalized data method on the class. So this is our main method to normalize all the data. So what it does is it connects to MySQL, which is like establishes a connection. And then we're going to go through and process restaurants, categories, dishes. Boom. Like as you remember yesterday, we had to write that like cleanup script to process categories. So we learned our lesson here and we prompted it accordingly to include the categories. So if we step into this process restaurants, we can see that we've got a query here where we just select star, which means all from that table that we were looking at here, this OMFRI. And when you select star, it just selects all of these fields. So we'd get like the ID, the name, the brief description, address, town, state, phone, county, country. Lat long's huge. Remember we didn't get that yesterday, so this will be huge. So what's going to do is it's going to execute that query. So if I can run, I can just copy this and run this. So you guys can see like what comes back. Boom. So there you go. We get back all these lovely records. So that's exactly what's happening here. We're executing and then we're fetching all those rows. So then we're looping over all those rows. We're creating a document ID. So we're building that address. We're getting that address 1, 2, city, town, state, province. And we've got that here in the table. Where is it? Yeah, there you go. Address 1, address 2, city, town, state, province, postal code. So we get all those, we build that address, then we add that address, get the name, get phone, website, lat long, postal code, appending some search words by this generate search keywords method that we've got here, and then so we're storing the mapping for the dishes. So I'm not really sure what this is doing. Oh, so this is creating a dictionary of restaurants keyed off of the OMF ID. That'll be huge for when I believe it goes through and then links all the dishes to it. So if I'm guessing after that process restaurants, we process dishes with the category, and I'm assuming that category is going to do the same thing. I'm going to run a query. So yeah, let's run this query, see what's good. Oh, cool. So we get so many categories. Oh my goodness. These definitely need to be cleaned up. Right? Like, cool. So yeah, that's what this is going to do. Again, it's going to execute that query that we just executed. It's going to fetch all the rows. It's going to loop through the rows. We're going to get the group name. If it's in the categories, we're going to skip it. We've already processed. We're going to generate a unique ID, and then we're going to create that category document. Again, we're creating a dictionary. We're instantiating up here. This in Python means dictionary, and that's just a key value pair. So it'd look like key and then value. So then we're storing that mapping, and then that's that. Jeez. I don't know if you guys can hear that blender in the background. It's going crazy. Jeez. Must be a really smooth smoothie they're blending over there. So the last thing we're going to do is process those dishes, where we have this beast of a query right here. We're going to execute that query. So let's execute that query. Oh my goodness. Cut it out. Oh my gosh. I literally just want to paste a query. No, I don't want to exit. Cool. So this, we're getting all the menu item ID, name, description, price, seems vegetarian, gluten-free, kosher, all that stuff. Looks awesome. Looks awesome. Cool. Oh, so we're joining on the menu group, so we can get the group name. That's awesome. So, okay, so this is an instance right here of where we, okay, this is crazy in the background. Like, what are they making back there? Like, that cannot be I'm so curious of what's in the smoothie, what's making it so loud, so long. So as an example, we're joining menu groups on the menu items. So we're joining that groups table onto the menu items table by that group ID. So yeah, the menu items has that group ID. So we're joining on these menu groups table by that ID. So like where this ID matches that ID, we're joining it and then we're grabbing that group name. So in that way we know like this menu item is a pizza, this menu item is a appetizer, is a pasta. Very cool. So then we're executing that query, we're getting all of the rows, creating these sets for unmatched restaurants and unmatched categories. Ref, this is not, okay. I mean, I guess this is fine. For the normalizer, we're just like storing that reference to the restaurant and to the category. So just remember, like yesterday in the importer, we had that issue where we were storing this actual string in the database and we weren't storing the ref itself. So this is going to have to be cleaned up in the importer script, or at least I hope that it kind of gleaned from what we did yesterday and then implements that. So then, yeah, go through, parse the dietary restrictions, same thing, create the doc ID, then we create that document, and then we're going to append that document. Cool. I really hope that's the last time I did that because that's just so loud and distracting. So then, cool. We process those. After normalizing that data, we get that data and then we save it to the JSON. So that just, boom, puts it out to JSON. So let's go ahead and run this after going through it. Always good to go through the code before you run it. So here you go, we're running some code. Oh my gosh, that's my password right there. I'm definitely gonna blur that out. Probably shouldn't even be printing that to begin with. Whatever, just add some blurs in there, which is fine. But as you can see, we're processing restaurants from the table. We've got 313,000 restaurants. Oh my gosh. And then we're processing categories from that menu groups. We've got 65,000 of them. And then we just processed, holy cow, we just processed 1,384,000 dishes. So then we get a bunch of little info that we closed the MySQL connection, we saved the restaurants, we saved the categories, and I assume that it's going to take a long time to save the dishes because there is 1,384,000 of them. So as you can see, our normalization is complete. We got all of our documents for the restaurants, categories, and dishes. That's awesome. That's awesome. Let's go ahead and check that. Let's look at our restaurants, make sure everything looks good. This is incredible. In the structure we want, we've got ID, name, address, phone, website, location. Huge, we got the lat long this time. Remember yesterday, we didn't get lat long from open table scraper, but this is open menu. They do things a little bit differently. So yeah, it's just like so many of the same restaurants, but cool how it's in different locations. Probably won't even let us view this, it's so big. Let's open it anyway. If I'm gonna break, I'm not even gonna bother. And then categories, let's see what's going on. This is also probably super big and it's not even gonna open. Yeah, oh, awesome. So then we get our unique ID, our name, keywords, awesome. Awesome. So look, we just normalized all of our MySQL data into JSON document data that's ready to then be parsed and put into Firebase. This is how we work. This is how we roll. I don't even know how long this video's been, but it's been about like 20 minutes. So let's go. That's awesome. Yeah. I'm gonna save this importer for another video. All these videos are starting to get kind of long, and this is a lot of data. As we saw, we've got hundreds of thousands and even millions of records. So this importer script is gonna have to be extremely robust, and we're gonna have to have like a backout feature to where if it's messing up, or our input data or the data that we're inputting is being wrong, or the data being inputted is wrong, we're gonna have to like back that out so that we don't mess up our current database with all the data we have in there. All the data that we put in yesterday. It's just a lot of data, and I want to make sure that it's right. So really important that we get it right, take our time, plan, like really go through this script, make sure everything's looking good. So yeah, we'll save that for next video. This video, just kind of want to show you my process for kind of taking a step back, building some requirements, like looking through your problem. So my problem was I had MySQL data. I had to go through, understand that MySQL data, how it was structured, and then go ahead and put that just into some context that I give to cursor, and then understand that data, and then in the context, provide great context to the cursor agent of how we want the script to work, what is the structure of our MySQL, and then what is our desired structure of Firebase that we're trying to normalize to. So then I add that to cursor, and then I prompted it to go ahead and build this normalizer script and this importer script. And then what we did in this video was we went through the normalizer script, we went through the current data structure, our new data structure. We reviewed the normalizer script to understand how it works, because if you don't understand how it works, you're not going to understand why it breaks. Okay, this is a key thing to ingrain into your brain as you start coding with AI, is you need to understand how it works. Because if you don't, then you won't know why it broke or how to fix it. Yeah, so that's all for today's video. Hope you guys enjoyed. As always, playing some bangers here. But yeah, if you guys made it this far, appreciate you as always, and thanks for watching.